We can have also some nested lists comprehension. For example, we have a matrix, like we have lists of lists, and it's a matrix, and we can transpose this matrix. We can transpose it the way it is done here. We can see if, for example, this one is a bit more complicated. We can try to see how we do it. First, we try to create a transposed matrix, which is a transposed list, which is empty, and we do the outer loop, and we can append for each loop. We can for each iteration we can append the row of I. Row for row in matrix. So for row in matrix, this is row in matrix, and we'll append the row of I, this one, and we will just append the row of I, row of 0, row of 1 in vertically. We transpose it, or we can do it even just in a more planar way. This one is still using the list comprehension here. Here we can also flatten this list comprehension in here without using it. So with list comprehension, you can really go from 7 lines of code to 1 line of code. Here we have also a quite interesting, or you can do it just with built-in functions. Built-in functions, they are really strong and really they really save a lot of time. In here you have for example the zip, like list of zip, and you can zip the contents of the matrix. You can just unpack the matrix and try and zip it. So it will zip this one. It will zip them like this. It will combine these elements with these elements with these elements in a tuple. We'll see what is a tuple. It's like just think about it like a list. We have talked about it. It's like just some immutable lists. They are like rows in a table or something. We'll go into it here, and this is what zips do, and it makes them like here. So it transposes the matrix as well.